All right, so now we're going to be talking about quadratic functions. Quadratic functions. Quadratic functions are nonlinear because they form something called a symmetric curve on a graph. This symmetric curve is called a parabola. So we will get into graphing in our next standard, but just know that when we're dealing with a quadratic function, it creates a symmetric curve which actually looks like a U-shaped graph, and this is called a parabola. Now, all of these quadratic functions are going to have a degree of 2 on your x. Your y should still have a degree of 1. So for example, the following equation, y is equal to 2x squared minus 3x plus 4, this would be a quadratic equation because your x has a degree of 2, and your y is still just being raised to the first power. So we will be solving quadratic functions, but let's learn 3 different forms of quadratic functions. Just like with linear equations, we learned slope-intercept form, standard form, and point-slope form. Now with quadratic functions, we're going to learn 3 different forms as well. The first form that we're going to learn is standard form. That is in the format of y is equal to ax squared plus bx plus c. Y must be isolated, and your a value cannot be equal to 0 because, for example, if a was 0, then we would have the equation y is equal to a 0x squared plus a bx plus a c, which is 0 times an x squared would just wipe that term out, and we'd be left with the equation y is equal to bx plus c. And this would no longer have a degree of 2, and so it would become a linear equation, not a quadratic equation. However, you can have your b or c value be 0. For example, if we had the quadratic equation y is equal to negative 3x squared plus 4. This is technically in standard form. You just have a b value of 0 because this was is technically y is equal to negative 3x squared plus 0x plus 4. So this would still work. And then also your c could be 0. So maybe you have y is equal to a 7x squared minus a 3x, and then you don't have a constant, so technically your c is 0. This would also be considered standard form. And then you can have an a, b, and a c, like in the example that I wrote up here. This is also in standard form. Now we use standard form when we are solving a quadratic equation, which is what we're going to be doing in this standard. So we will be transforming our equations into standard form when solving and coming up with the solutions of a quadratic equation. But you can also use standard form when graphing, but we'll learn graphing in our next standard. Now let's move on to a different form called vertex form. Vertex form is in the form of y is equal to a times x minus h plus k, where h and k are your vertex of your quadratic equation. We can use vertex form when we are graphing. So some examples of vertex form, you can't have a be equal to 0, but you can have a be equal to 1. If I have a as 1, I don't need to actually write it. So this is technically vertex form here. You could also have y is equal to, and you can actually have an a value greater than 1 or less than 1. So maybe 7, and then maybe you have x minus 0 squared plus 1. This is still considered vertex form even though your h value is 0. And then I'm going to give you one more example. Y is equal to negative 2 times x minus 1 squared. And then maybe you don't have, maybe your k value is 0, and that's okay. And you don't have to write plus 0 on the end, but that's technically still in vertex form. And then lastly, factored form. Factored form can be used to solve a quadratic equation and also graph a quadratic equation. So it's in the form of y is equal to x minus r1 times x minus r2. I know that I'm using all these different variables here, but a reminder that a, b, and c in standard form are just going to be filled in with numbers. A, h, and k are going to also be filled with numbers, and h and k would be your vertex of the parabola, which we'll talk about more about that when we do graphing. And then lastly, R1 and R2 would be filled in with numbers, and R1 and R2 would actually be your roots or your solutions to your quadratic equation. And we'll talk about that as well. So an example of factored form could be something like this. Y is equal to x plus 3 times x minus 2. Or you can also have y is equal to, and you could actually have a number in front of your x, and that would still be okay. This would also be in factored form. All right, so for numbers 1 through 8, we're going to identify what format the quadratic functions are in, whether it's standard, vertex, factored, or maybe none of those. All right, so number 1, y is isolated, and we have it in terms of ax plus bx, although it's minus bx, and that's okay, plus c. So this would be standard form. In all of the forms, y needs to be isolated, and in number 2, y is not isolated, so this would be none. Number 3, I have y is equal to a 2x minus 1 times an x plus 2. Since I have two quantities being multiplied by one another, this is in factored form. Number 4, y is isolated, and I have it in terms of a times x minus h squared, but this is x plus h squared, and that's fine, and then plus k, or again, this is minus k, and that's okay as well. So this is actually vertex form. All right, number 5, I have it in terms of y is equal to a times x minus h squared. And then remember, your k value is 0 here, and you don't have to write the 0 on the end, but this then would be vertex form. Number 6, y is isolated, and we have it as ax squared plus a 0x plus c. In this case, it's minus a c, and that's okay. But technically my b value is 0 here, so this is still considered standard form. Number 7, okay, y is isolated. Even though the y in the other part is flipped around, that doesn't mean anything. You can flip it back and it's still the same thing. So we have this in terms of y is equal to ax squared plus bx plus c, so this is standard form. And then number 8, I have this in terms of y is equal to a quantity times a quantity. That is factored form. All right, so now in this standard, we are going to be solving quadratic equations. So the solutions of quadratic equations actually have many different names to it. If I asked you find the roots of the quadratic equations, that's really actually meaning find your solutions. If I ask you to find your zeros of your quadratic equation, again, that means the solutions. And then this is an interesting one, and we're going to talk more about this. X-intercepts, if I asked you to find the x-intercepts of your quadratic equation, this also means the solutions to your quadratic equation. Now, a quadratic equation can have 2, 1, or 0 real numbers, and I'm going to explain why. For example, if I have a coordinate graph, And my quadratic equation looks like this. Remember, the solutions, as stated above, are actually the x-intercepts of your graph. Well, in this situation, I have 2 solutions. So this is an example of a quadratic equation having 2 solutions. Let me draw another coordinate plane. Another example, your quadratic equation could look like this, where it only touches the x-axis at one point. And again, your solutions to a quadratic equation, really we're finding the x-intercepts on the graph. And so since this only touches the x-axis 1, this type of quadratic equation would just have one real number solution. And then lastly, the only other example that could possibly take place on a quadratic or on a coordinate plane would be something like this, where this is not going to cross anywhere on my x-axis. However, we need to specify that this has 0 real number solutions. In algebra class, we're only talking about real numbers. However, when you guys get to Algebra 3-4 and the higher level math, you guys will talk about imaginary numbers. And technically, this graph has imaginary solutions. So I don't want to just specify this as 0 solutions, because technically there are solutions, but they're imaginary and we're not going to be learning about those yet. So make sure that you specify that this type of graph or this type of quadratic equation would have 0 real number solutions. And then when you learn more about quadratic equations in higher level math classes, you could actually find the imaginary solutions. But for right now, it's 0 real number solutions because we're only dealing with real numbers in algebra. All right, that brings us to the first level 1 lesson, and you're going to have one more level 1 lesson to complete, so before you do some more practice.